scientific establishment that if you talked about UFOs, you were pretty much relegated to being a nutcase, and the giggle factor kicks in, right?
Yeah.
But things have changed then, because of the fact that the military is now basically releasing hours of videotapes of things that defy the normal laws of physics.
Something just happened in the darkness between stars. An object, traveling through the void for millions of years, has entered our solar system. But this isn't just another comet passing through our cosmic neighborhood. This is 3I-Atlas, and it just released a signal that scientists can't explain. The data is real, the measurements are verified, and the implications are staggering. On a cold October night in 2024, the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, detected something extraordinary. Moving through the constellation of Ursa Major, a faint streak of light appeared on the observatory's digital sensors. At first, astronomers thought it was routine, another comet, another celestial wanderer making its way through the solar system. But as the data accumulated, something became clear. This object wasn't following the rules. Its trajectory didn't match anything born in our solar system. The numbers told an unmistakable story. This visitor came from interstellar space. This was 3I-Atlas, the third confirmed interstellar object ever detected by humanity. The discovery alone would have been remarkable. Only twice before had we identified objects from beyond our solar system's gravitational embrace. The first was Oumuamua in 2017, that strange cigar-shaped mystery that defied conventional explanation. The second was 2I-Borisov in 2019, which behaved more like a typical comet, but still carried secrets from another star system. Now we had a third. Astronomers around the world turned their instruments toward this new arrival. Radio telescopes swiveled, optical arrays focused. The James Webb Space Telescope adjusted its mirrors to capture every photon reflected from this distant traveler. What they found would challenge the very foundations of our understanding.
And the military has admitted that, quote, they're not ours. Before, there was always that ambiguity that maybe it's a new stealth bomber or a new fantastic device being prepared by the military. Nope. The military now admits that they're not ours. Then the question is, whose are they then?
Yeah, the signal itself operates in the microwave spectrum, specifically between 1.4 and 1.6 gigahertz. This range is significant. It falls within what scientists call the water hole, a region of the electromagnetic spectrum relatively quiet from cosmic background noise. It's the same frequency range that SETI researchers have long monitored, believing that any intelligent civilization attempting interstellar communication would choose these frequencies for their clarity. The fact that 3I/Atlas emits energy in this specific band raises questions that make astronomers uncomfortable. Is it coincidence? Or is there something about this frequency range that emerges naturally from unknown physical processes we've yet to understand? The data gets stranger when we examine the object's composition. Unlike typical comets, which are essentially dirty snowballs of ice and rock, spectroscopic analysis of 3I/Atlas reveals an unusual abundance of metallic elements. Iron, nickel, and traces of rare earth metals appear in concentrations far higher than expected. The object's albedo, its reflectivity, fluctuates in ways that suggest a surface that's not uniform. Parts of it absorb nearly all incoming light. Other sections reflect with unexpected efficiency. This patchwork appearance has led some researchers to propose that 3I-Atlas isn't a single cohesive object at all, but rather a loose aggregate of materials bound together by weak gravitational forces. Then there's the trajectory. Every object in our solar system follows predictable paths governed by the gravitational influence of the Sun and planets. Even interstellar objects, once captured by our Sun's gravity, should behave according to these immutable laws. But 3I Atlas exhibits what astronomers call non-gravitational acceleration. It's moving slightly faster than it should be based on gravitational calculations alone. Oumuamua showed similar behavior, leading to wild speculation about solar sails and alien probes. With 3I Atlas, the effect is more pronounced. The object accelerates as it approaches the Sun, then maintains velocity in ways that suggest something other than simple outgassing is providing thrust. Dr. Kaku proposed several possibilities, each more intriguing than the last. The first and most conservative explanation suggests we're witnessing a new type of cometary sublimation. Perhaps exotic ices, formed in the frigid depths between stars, undergo phase transitions at temperatures different from the water ice we're familiar with. These sublimations could create jets of gas that propel the object in unexpected directions, while simultaneously generating electromagnetic emissions through charged particle interactions. It's plausible. It's grounded in known physics, but it requires comet composition unlike anything we've previously documented.
To be that one person would see something in the sky and say, look, Martha, look, there's something up there. Now things have changed. Now we have multiple sightings by multiple modes. That is the gold standard for looking for these objects. Not just one person, but several people that are reputable.
The third possibility is the one that keeps astronomers awake at night. What if we're not looking at a comet at all? What if 3I ATL is something else entirely? The hypothesis seems impossible at first, but consider the evidence. An object arrives from interstellar space. It emits structured electromagnetic radiation. It contains unusually high concentrations of metallic elements. It accelerates using mechanisms we can't fully explain. These characteristics, taken individually, might have natural explanations, but together they form a pattern that some researchers believe deserves serious consideration. Could this be an artifact, a probe sent from another civilization, not necessarily to communicate with us, but perhaps to study our solar system, collect data, and continue on its journey through the galaxy? The scientific community remains deeply divided. Most astronomers favor natural explanations, believing that we simply haven't encountered enough interstellar objects to understand their full range of behaviors. The universe is vast and ancient. The processes that form celestial bodies in other star systems might produce structures and compositions wildly different from our local experience. What seems anomalous might simply be normal for objects born in different stellar environments. These researchers point out that every time humanity encounters something new in space, we first think it's unprecedented, only to later discover it fits within natural phenomena once we understand the underlying physics. But a vocal minority of scientists aren't satisfied with these reassurances. They point to statistical improbabilities that continue to mount. The odds of an interstellar object randomly entering our solar system are already vanishingly small. The fact that it then exhibits multiple anomalous characteristics strains coincidence beyond breaking. They cite the principle of Occam's razor, but in reverse. Sometimes the simplest explanation isn't the most comforting one. Sometimes the data is trying to tell us something we're not ready to hear. The signal continues as 3I ATL moves deeper into our solar system. Multiple observatories have now confirmed its existence. The European Space Agency's Deep Space Network detected it independently. The Chinese 500-meter aperture spherical telescope, FAST, recorded the same frequency patterns. The consistency across independent observation platforms eliminates the possibility of instrumental error or localized interference. Whatever is generating this signal, it's real, it's measurable, and it's coming from 3I ATL. Dr. Kaku has called for a coordinated international effort to study the object before it leaves our solar system forever. The window of opportunity is narrow. Based on current trajectory calculations, 3I ATL will reach its closest approach to Earth in approximately 18 months. After that, it will slingshot around the Sun and begin its journey back into interstellar space, accelerating to velocities that will make further observation impossible with current technology. If we're going to understand what we're seeing, we need to act now. Some researchers have proposed an ambitious mission. A fast flyby probe, launched using advanced propulsion systems, could potentially intercept 3I ATL before it departs. The spacecraft would carry instruments designed to analyze the object's composition, map its surface structure, and most importantly, determine the source of the electromagnetic emissions. The technical challenges are immense. The object is moving at over 30 kilometers
Not just
per second.
radar, but visual sighting, infrared sensors, telescopic evidence. Now we have multiple sightings by multiple modes. And so the burden of proof has shifted. It used to be the burden of proof was on the people who believed in UFOs. They saw something, prove it. Now the burden of proof has shifted.
Second, relative to our frame of reference. Matching velocities, even briefly, would require propulsion technology at the edge of our current capabilities. But the scientific return would be unprecedented. We would, for the first time in human history, directly sample material from another star system, while simultaneously investigating an anomaly that could rewrite our understanding of natural processes or confirm we're not alone. The implications extend far beyond astronomy. If 3I/Atlas is indeed natural, but operating through unknown physics, it suggests our models of cometary science are incomplete. We would need to revise our understanding of how objects form in interstellar space, what compositions are possible, and how they interact with stellar environments. This would have profound effects on our theories of planetary formation, the distribution of organic molecules throughout the galaxy, and the potential for life to arise in diverse stellar systems. But if the object is something more, if it represents the first confirmed artifact from another civilization, the implications become existential. It would mean we're not alone in the universe. Not just in the abstract sense of believing microbial life might exist on distant worlds, but in the concrete reality that intelligent beings exist, that they build things, that they send those things into the cosmos, and that one of those things has arrived here. The philosophical and societal impacts would be immeasurable. Every assumption about humanity's place in the universe would need reevaluation. Dr. Kaku has emphasized the need for scientific rigor in these discussions. The excitement surrounding 3I Atlas must be tempered with methodical analysis. Extraordinary claims require extraordinary evidence, and while the data is certainly unusual, it hasn't yet crossed the threshold that would compel us to abandon natural explanations entirely. But he also warned against premature dismissal. Science advances by investigating anomalies, by taking seriously those observations that don't fit our current models. If we dismiss 3I/Atlas simply because its behavior makes us uncomfortable, we risk missing a genuine discovery. The object continues its journey. Every night, radio telescopes track its position, recording data that fills terabytes of storage. Astronomers analyze spectral lines, searching for clues in the light reflected and emitted. Mathematical models run on supercomputers, attempting to simulate every possible natural process that could explain what we're seeing. And still the signal persists, regular, structured, unexplained. There's a particular irony in this moment. For decades, humanity has actively searched for signs of extraterrestrial intelligence. We've built radio telescopes to listen for signals from the stars. We've scanned thousands of exoplanets for signs of atmospheric biosignatures. We've sent messages into space hoping someone, somewhere, might receive them. And yet, if 3I/Atlas represents our first genuine contact with evidence of another civilization, it didn't come from a distant star system light years away. It came to us. It entered our solar system. It moved through our neighborhood in space, close enough for our instruments to detect, analyze, and wonder. The comparison with previous interstellar visitors becomes unavoidable. Oumuamua, the first, remains controversial. Its elongated shape, unusual tumbling motion, and unexplained
did to the Pentagon, to the military. Now they have to prove that these aren't extraterrestrial. And so I think there's been a sea change in the last just several years. 50 years ago, there was a congressional hearing, and it was coming out of Project Blue Book. And there was a lot of laughter and a lot of jokes about things.
Its acceleration sparked debates that continued to this day. Harvard astrophysicist Avi Loeb famously proposed it could be an alien light sail, a suggestion that drew both serious consideration and significant criticism. 2I, Borisov, by contrast, behaved more conventionally, resembling comets from our own solar system closely enough to seem almost reassuring in its normalcy. Now, 3I Atlas forces us to confront the pattern. 3 interstellar objects. 3 different sets of unusual characteristics. Are we seeing natural variation in the population of objects drifting through the galaxy, or are we witnessing something more? The statistical analysis is sobering. The estimated number of interstellar objects passing through our solar system at any given time is substantial, perhaps thousands, but most are too small or too distant to detect with current technology. The 3 we've identified represent the largest and most observable specimens. If these 3 all display anomalous characteristics, it suggests that unusual behavior might be common among interstellar visitors. This either means our theories about cometary formation and behavior in interstellar space are fundamentally flawed, or we need to seriously consider alternative explanations for what these objects might be. Dr. Kaku has been careful to frame the discussion in terms of scientific investigation rather than speculation. But in private conversations and interviews, he's acknowledged what many astronomers are thinking. We're living through a unique moment in human history. For the first time, we have the technology to detect objects from other star systems as they pass through our cosmic neighborhood. For the first time, we can analyze them in detail, measuring their properties and behavior. And what we're finding doesn't always match our expectations. This could be the beginning of a revolution in our understanding of the universe, or it could be something even more profound. The signal from 3I Atlas continues to pulse through space, carrying whatever message or meaning it contains. Is it the echo of exotic physics we've yet to master? Is it the natural song of materials forged in alien star systems? Or is it something else entirely, something that will change humanity's understanding of its place in the cosmos? The answer approaches with each passing day as the object draws nearer. We stand at a threshold. Behind us lies everything humanity has learned about the universe through centuries of observation and analysis. Before us lies a mystery that could reshape that understanding completely. Soon, very soon, we'll know more. New data arrives daily. Analysis continues around the clock. And somewhere in that flood of information might lie the answer we're seeking. The answer to what 3I Atlas truly is. The answer to what the signal means. The answer to whether we are alone. Until then, we watch. We measure. We calculate. And we wonder. Because that's what humans do when confronted with mystery. We seek understanding. We push against the boundaries of knowledge. And sometimes, if we're fortunate, the universe answers back. Perhaps 3I Atlas is that answer. Perhaps this signal, this strange electromagnetic whisper from an object born under alien skies, is the cosmos telling us that there's more to discover than we ever imagined. More wonders to witness, more questions to ask, more mysteries waiting in the darkness between stars. We stand on the edge of discovery. Soon, we'll know if this is just an unusual comet or a message written in physics we're only beginning to read. The signal continues, and humanity listens. The mysteries of our universe are unfolding in real time, and 3i Atlas is just the beginning. If you want to stay at the forefront of cosmic discoveries and explore the enigmas that challenge everything we know about space, subscribe now and join our journey into the unknown. Hit that notification bell because the next signal we detect could change everything. Don't miss what comes next.